We're going to start this quarter talking about chemical formulas. A chemical formula is a shorthand way to tell the identity and amount of elements in a chemical compound. The empiric formula is the simplest formula that tells only the relative proportions of the elements. An oxidation number is used to write your chemical formulas, so you need to understand what an oxidation number is. An oxidation number is an imaginary number representing the number of electrons which an element must gain or lose to return to its neutral state. We'll talk about oxidation numbers in just a minute here. So here are some examples of different types of chemical formulas. These are two chemical formulas for benzene. This is the empiric formula, CH, and the molecular formula, C6H6. Notice the simplest formula, the empiric formula, shows simply the relationship between how many carbons and how many hydrogens there are, which is 1 to 1. But the molecular formula shows actually how many of each atom is contained in the compound benzene. These other two formulas that are shown here show somewhat the spatial structure of the benzene molecule. Here's an example of hydrogen peroxide. And the empiric formula, again, is HO, 1 to 1. The molecular formula, H2O2, hydrogen peroxide. Now, what are the rules for determining the oxidation number for any particular element in a compound? The oxidation number for any free element, that is a element that's by itself, like chlorine, iron, etc., is always 0, because you don't have to add or subtract any electrons in order to return it to its neutral state, because it's already in its neutral state. So the oxidation number of all elements are 0. The oxidation number of a monoatomic ion, monoatomic means having one atom, so a one atom ion is equal to the charge of that ion. So for example, chlorine minus has an oxidation number of -1 because of the minus charge. Sodium plus has an oxidation number of +1. The sum of the oxidation numbers of all the atoms in a compound must sum up to 0. And this is the zero-sum rule. The sum of the oxidation numbers in a polyatomic ion. A polyatomic ion is an ion that contains more than one atom, and we'll show you examples of that in just a few minutes, must equal the charge of that ion. Elements in certain families regularly have the same oxidation number, the specific oxidation number rule. So for example, 1A elements, the first column on the left of the periodic table, the oxidation number is almost always 1, +1. Conversely, on the other end of the table, the halogens, the 7A elements, the oxidation number is most commonly -1. But you notice I use the word almost always and most commonly because there are exceptions to these rules. To this rule, I mean. So you have the 1A elements that are usually +1. The 2A elements are usually +2. Hydrogen is usually +1 when bonded with a nonmetal and -1 when bonded with a metal. Remember, the metals are on the left side of the periodic table. Nonmetals are on the right side. Oxygen is always -2 except when bonded with fluorine. And group 7A halogens are -1 when bonded with metals. So these rules, it's important for you to keep these rules in mind, and I'd spend a little time memorizing these rules because you need to be pretty quick with these in order to write chemical formulas and in order to write chemical formulas. Now the transition elements, which are shown here, these are the elements in the middle of the periodic table. They tend to have variable oxidation numbers depending on what they're combined with. So there are no real solid rules for how to determine their oxidation number other than looking at the compound as a whole and figuring it out from that. So here's an example of how you would go about determining an oxidation number. I said that hydrogen is usually a +1 when bonded with nonmetals, and sulfur and oxygen are almost always nonmetals. And so hydrogen is a +1. Oxygen is always a -2. And so you end up with the total here, 2 times +1 is +2, 4 times -2 is -8. Now the other rule states that this compound, the sum of the oxidation numbers of this compound has to be 0. So what would sulfur have to be in order for that to be 0? And here's another example. You have chromium and oxygen. Again, you have 7 oxygens, and so that's -14, and 2 chromiums. And you have to add those up to get and end up with a -2 because that's the charge. Remember the ion rule. So it's 2 times some oxidation number for chromium plus 7 times, or plus a -14, 7 times a -2, has to end up equaling a -2. And the only way that would happen is if chromium is a +6. The answer to the first one, sulfur has to be a +6 in order, an oxidation number of +6 in order for that to follow all the rules. So let's do some practice here. Give the oxidation number for each element in each of these compounds or ions. This will be on the quiz or test. So let's take a look at how we would go about doing that. So let's start out with this one. This is calcium carbonate. And we know that oxygen here is -2. And we look up C on the periodic table, and it's in the 4A element. So it's likely to be +4. And so we start out with, actually let's do it this way. Let's look at calcium is a 2A and it's +2. So we know that calcium is most likely +2. So that's +2 plus some value for carbon plus 3 times a -2. And this is a compound, so this has got to equal 0. So this is -6 and +2. So what does carbon have to be? And it's +4, as I said a minute ago. Let's look at the next one, HF. This is pretty straightforward. F is always -1, or almost always -1. So that makes hydrogen has to be a +1. Again, in order for this to work out to 0. KMnO4. Again, -2. This is a 1A element, so this is +1. So we start out with 1 plus something, x, plus 4 times a -2, and all of that has to equal 0. So 1 plus something -8 has to equal 0. So that means that Mn has to be a +7. So it's +7. K2CrO4. This is -2 plus 1. So 2 times +1 plus something plus 4 times the minus 2 has to equal 0. So this is minus 8. And this is plus 2. So what does this have to be but a plus 6 for that to balance out to equal 0? And the last one here is a little more complicated. NaC2H3O2. Hydrogen is combining with a non-metal, so it's a plus 1. This is minus 2, and this is plus 1. So we have 1 plus 2 times something, 3 times 1 plus 2 times a minus 2 has to equal 0. So we have 1 plus 2 times something plus 3 minus 4 has to equal 0. Now lo and behold, it's 2 is equal to 0, so X has to be equal to 0. So in this case, carbon is actually, its oxidation number is actually 0. And remember, these numbers are imaginary, and so they can come out unusual like this. So this case, it's 0. So the rules for writing the chemical formula are as follows. First, you write down the symbol for each element with the least electronegative first. Remember that elements on the left side of the periodic table are less electronegative. Elements on the right side of the periodic table are more electronegative. So you usually start with the least electronegative first and then the most second. Then you use the rules to find the oxidation number for each element. And then once you find these oxidation numbers, then you use subscripts to balance the oxidation number so that the sum is 0. So at the bottom here we have 4 examples. We're combining hydrogen and oxygen. Hydrogen is, when combined with a nonmetal, is a plus 1. Oxygen is a minus 2. You have to take 2 times plus 1 to counterbalance the minus 2 so that it ends up being a 0. So that's H2O, or water. Barium is a 2A element, and so it has a plus 2. Bromine is a 7A element. It's a minus 1. So you have to multiply the bromine by 2 in order for it to balance out the barium and end up with a 0. Sodium is a plus 1. Phosphorus is a 5A element, minus 3. So you have to multiply the sodium times 3 in order to get a 0 sum. And then the last, aluminum is a plus 3. It's a 3A element. Sulfur is a minus 2. The least common multiple between those two is 6. 3 goes into 6 2 times, so it's 2 aluminums. And 2 goes into 6 3 times, it's 3 sulfurs. So let's look at some practice here. What's the formula for potassium and oxygen? Okay, potassium is K, and it's less electronegative than oxygen, so we'll put it like this. K is plus 1, O is minus 2. The least common multiple between these two is 2. 1 goes into 2 2 times. 2 goes into 2 1 time, and you don't write the 1, so the formula is K2O. Hydrogen and fluorine, HF. This is a minus 1, this is a plus 1. These are already written as they should be, HF. Magnesium, sulfur. Sulfur is a 6A element, it's a minus 2. Magnesium is a 2A element, it's a plus 2. The least common multiple here is 2. 2 goes into 2 1 time, 2 goes into 2 1 time, so it's MgS. You don't write the ones down. Lithium iodide. This is a minus 1, 7A element, plus 1, 1A element. Again, least common multiple is 1, so it's Li. And then last, barium and nitrogen. Nitrogen is a 5A element, so it's minus 3. Barium is a 2A element, it's plus 2. Least common multiple is 6. 2 goes into 6 3 times, so it's barium 3. Oh, excuse me. 3 goes into 6 2 times, so it's Ba3N2, barium nitride.